All right, people. I believe everybody is doing great, nice, and absolutely fine. Let me know in the chats if I'm perfectly audible and visible to each and every one. Okay, so that we can move on in our live session. Okay. So what's up, people? I believe everybody is doing great, nice, and absolutely fine. Today we have the question practice session. Okay. And in this particular session, we will be targeting some of the important questions out there, which has the chances, maximum chances that they can be asked in the NEET, okay? So that we can revise the concepts also through these problems. And if you have not liked the session yet, like it as soon as possible and let the people join. We are starting accordingly. If you have not subscribed to the channel, I want you guys to subscribe to the channel as soon as possible. As soon as possible. Okay? That's mandatory. That's mandatory. So, what's up, what's up, what's up, what's up? And make sure, guys, you join our Telegram channel because that's important, because every single time we keep on sharing the notes in our Telegram channel only. Everybody out there, so fire in the chats. And if you have not liked the session yet, I want you guys to like it as soon as possible, because liking the session is mandatory. Marking the attendance is very much mandatory out there. Okay. Okay. Great. So good morning. Okay, so we have only few days left for the NEET, okay? Just the 20 days or something like that. And I know you guys are having the anxiety right now, but definitely we are going to kill it because we have been preparing since very long time. So let's basically start this particular session. And before this, I want you guys to join our Telegram channel, that is Unacademy NEET English. Okay, this is the link of that Telegram channel. I want you guys to join it as soon as possible. Okay, join it as soon as possible. Okay, you can join it later on, but do join it. Okay, that's mandatory. So we have the first question on the screen over here, that is from the ray optics, and this was the question which was asked in VCSR JEE mains. This was the question which was asked in JEE mains 2021 or 2022, I guess. Okay. Now listen to me very carefully. There is some Yavar Manzoor in the chats, and I don't know who is that guy. Okay, that's not me. Okay, he might be the student. Okay, but that's not me. Let me just clear that out over here. Now see, we have got over here two plane mirrors are inclined to each other such that the incident ray on the first mirror M1 and such that the light incident on the first mirror M1 and parallel to the second mirror M2 is finally reflected from the second mirror M2. Okay, this is the complete detail over here you can see about this particular question. I'll show you directly how to solve this particular question and what does the questioner exactly say in this particular question over here. Okay, so listen to me very carefully over here, my dear friends. The questioner is saying that we are giving two plane mirrors. How many plane mirrors? We are given two plane mirrors. Okay. Let's suppose I am basically making the first plane mirror. This is the first plane mirror. And let's suppose I call it M1. Let's suppose I call it M1 over here. Okay. And then we have got one more plane mirror. That is what we call, we say, sir, M2 over here. This is the second plane mirror. That is M2. Okay. And my dear friends, angle between these two plane mirrors is given as theta. Angle between these two plane mirrors is given as theta. Okay. Then the questioner says the incident light ray falls onto the mirror M1. The incident ray falls onto the mirror M1. This is what we call the incident ray. I write it IR over here. So incident ray basically falls onto the mirror M1 over here. Okay, this is what the questioner is saying. Such that this incident ray is parallel to mirror M2. This incident ray is parallel to mirror M2. Okay. Then we know that, sir, if let's suppose this is the reflecting surface from this side, if this is the reflecting surface from this side, tell me one thing. If the incident ray falls onto the mirror M1, everybody knows that, sir, it will get reflected. So after reflection, we say it falls onto the mirror M2. It falls onto the mirror M2. After reflection, it falls onto the mirror M2. Okay. Okay. You can clearly see over here. So the incident ray is falling on the mirror M1. After reflection, this gets reflected and falls onto the mirror M2. And we know that over here, let's suppose this is the reflecting surface of this mirror. This is the reflecting surface of this mirror. Sorry, this is the polished surface and this is the reflecting surface. So when this light ray falls onto the mirror M2, we know that it will get reflected once again something like this. It will get reflected once again something like this. Now guys, this light ray becomes parallel to mirror M1. Okay, this is the final ray. I call this as final ray. Okay, and this one is the incident ray. This one is the incident ray, which is parallel to mirror M2 over here. And we are supposed to find, this is the detail asked in the question. We are supposed to find the angle between the two plane mirrors. We are supposed to find this theta over here. We are supposed to find what is the value of this theta. This is what we are supposed to calculate in this particular question. Okay. Now guys, listen to me very carefully. Listen to me very carefully. Listen to me very carefully. How do we exactly solve this particular session? Solve this particular question. Guys, let's talk about the plane mirror M1. This is the incident ray which falls onto the plane mirror M1. Let's suppose if I place a line over here, don't you think that I can call this line as normal? This is normal over here. Yes. Now guys, listen to me very carefully. If I say, sir, this is what we call angle of incidence. We say, sir, this is the angle of reflection. Okay, because we know angle between incident ray and normal is angle of incidence, and this is angle of reflection. Okay, and we have also studied, guys, this angle will be equal to this angle. That is the angle between reflecting surface, okay, and incident ray is equal to the angle between reflecting surface and this reflected ray. I hope you remember. Guys, tell me one thing. If this angle is given as theta, don't you think, sir, this angle is also theta? Why? Hey guys, these two lines are parallel over here. So the angle, this one will be equal to this one. Now, if this is theta, my dear friends, can I say this angle will be also theta? Because we have studied, I hope you remember that. If this is a reflecting surface, just a second. If this is a reflecting surface, okay, incident ray falls onto this one, reflected ray, it gets reflected something like this. This is the normal. I have told you before, this angle is equal to this angle. And this angle is also equal to this angle. We have discussed this before. Okay. Now, guys, listen to me very carefully. This is theta. This is theta. Tell me one thing. If this angle is theta over here, don't you think that, sir, this angle will be also theta? Don't you think that this angle will be also theta? Hey, yes, sir, 110%, because this line is parallel to this line. Now, guys, if this angle is theta, we say this angle will be also theta, because we can use the same logic. Guys, on this mirror M2, you can clearly see, on this mirror M2, we said this light ray is incident. This is the incident ray for mirror M2. This one is the reflected ray. This one is the reflected ray. Okay. Now, this angle between reflected ray and reflecting surface is equal to angle between incident ray and reflecting surface, both are equal. Now look at this particular triangle, theta, theta, theta. Don't you think that, sir, in this particular case, we can simply say 3 theta will be equal to how much? We say, sir, 180 degree. Sum of the interior angles over here. So we say 3 theta is equal to 180. Theta will be, we say, sir, 60 degrees in that particular case. So done and dusted with the particular question. So theta in this case is 60 degrees. Hey, tell me in the chats, is this crystalline clear to each and everybody? Let me know in the chats. And guys, if you have not liked the session yet, I want you guys to like the session as soon as possible. Okay. Now, we have got one more question on the screen. I want you guys to take a look in this particular case and Let me know what is the answer of this particular question over here. Everybody out there, everybody out there. Okay. Okay. Now, let's take a look on this particular question. An object is placed at a distance of 40 centimeters. Okay. An object is placed at a distance of 40 centimeters, I say. Okay. In front of the concave mirror. What does the questioner say? We have got a concave mirror over here. We have got a concave mirror over here. Just a second. So let's suppose we have got this concave mirror exactly over here. Okay. And my dear friends, we know concave mirror is polished from this side. Concave mirror is polished from this side. Okay. And this is what we call the principal axis. This is what we call the principal axis. This is the principal axis over here. Okay. Now guys, it says that an object is placed at a distance of 40 centimeters. This is the object. Let's suppose this is the object we have got over here. Okay. This is the object. And this object is placed at a distance of, we say, sir, 40 centimeters. This distance is over here, 40 centimeters. Okay. This is the object. And the focal length of the object, this mirror is given as, we say, sir, 20 centimeters. Okay, 20 centimeters. We are supposed to find the image will be produced at. We are supposed to find where is the image produced in this particular case. I have told you in these particular questions, we have to take care of the sign conventions. Guys, we have to take care of the sign conventions. If we say, sir, this is the direction of the incident ray. Why? Because incident ray leave from the object. So this is, we say, sir, incident ray. If this is the incident ray, can I say, sir, this side would be positive? Why? Because the direction of incident ray is considered to be positive. And we say this will be, sir, negative side, 110%. Now tell me one thing. Tell me one thing. We say, sir, object distance, that is u. Can I say in this particular case, u will be simply, that is, we say, sir, minus 40 centimeters. Okay. And when it comes to the focal length, can I say focal length in this case also is minus 20 centimeters? Why? Because u is from negative side. U means this distance of the object. And focus of this mirror is from this left side also. So we say that is also negative, minus 20. Okay. Now, my dear friends, what we are supposed to calculate in this particular case, we have to calculate over here, that is V. We know the formula. Tell me one thing. Have we studied, sir, 1 by F is equal to 1 by V plus 1 by U? Okay. This is what we have studied. Mirror formula. Now, if you put the values over here, 1 upon, what is the value of F in this particular case? Minus 20 is equal to 1 upon V we are supposed to calculate plus 1 upon what is U? That is, we say, sir, minus 40. And solo it, V will come out to be minus 40 centimeters. Is that clear? Is that clear? Let me know in the chats. Let me know in the chats. Okay, an important question. I want you guys to basically let me know the answer of this particular question. Is this crystalline clear to each and everyone? Is this crystalline clear to each and everyone? All the people out there? Guys, hit the like button if you have not liked the session yet, because that's mandatory. Everybody out there. Okay, now the question over here is, we have got an incident ray. We have got an incident ray. Okay. And guys, this is the rarer medium from the upper side. This is the rarer medium. And this is the denser medium. So it is asking that when the light ray is basically going from one medium to, let's suppose it goes into the another medium. Okay. We are supposed to find, in that case, find the critical angle over here. We are supposed to find in this particular case the critical angle. Can you tell me what is the value of critical angle over here? Can you tell me what is the value of critical angle over here? I hope you remember that concept when it comes to the critical angle. Guys, can you tell me what is the value of critical angle over here? What was the critical angle? Sir, that angle at which the reflected ray, at which the refracted ray makes the 90 degrees with the normal, that ray, that angle at which the refracted ray makes the 90 degrees with the normal. Tell me over here, guys. I'll tell you the answer of this question. We say no critical angle is made here. There will be no critical angle. Why, sir? Guys, I hope you remember the concept. When we were learning the concept of critical angle, what was that? We were saying that we have got over here, let's suppose this is the medium, that is, we say, sir, this is the rarer medium. Okay. And this is the denser medium. And I told you, if the light goes from denser medium to rarer medium, okay? If the light goes from denser medium to rarer medium, okay? And that value of this angle theta c, we say when the refracted ray makes the 90 degrees over here, this is, we say, sir, 90 degrees. This we were saying that this is the critical angle. So critical angle is only made when the light goes from denser medium to rarer medium, because then only light gets bent away from the normal. When the light moves from denser medium to rarer medium, we say light is bent away from the normal. So then only critical angle is made. Now in this particular case, see, light is moving from rarer to denser. So it will be bent towards the normal. So we say this is not the case of critical angle. So I hope you remember that. Let me show you the question. See. Same question, but in this case, light is going from denser medium to rarer medium. We say after refraction, let's suppose the light moves something like this, and this angle is made 90 degrees. Now tell me over here, how to find the value of this critical angle? Sir, this will be critical angle. So we say critical angle is that angle at which refracted ray makes 90 degrees with the normal. Okay. Now in this particular case, if I ask you to tell me what is the value of critical angle, what will you say? Sir, we say sine of theta c is equal to, I hope you remember, sir, mu r, that is refractive index of the rarer medium divided by mu d, refractive index of the denser medium. So we say, sir, sine of theta c will be simply, what is the value of mu r in this case? We say, sir, that is √3. So I'll write over here that is √3 upon, what is the value of mu d over here? Mu d is, we say, sir, 2 in this particular case. So we say, sir, √3 by 2. So can I say in this particular case, sir, theta c will be 60 degrees. So directly remember, my dear friends, critical angle is made only if the light goes from denser medium to rarer medium. If light moves from rarer to denser, we don't say critical angle is made in that case. Okay. Is that clear? Is this clear? Let me know in the chats, guys. Is this crystalline clear to each and everyone? Everybody out there. A ray of light strikes a glass. Okay, great. So a ray of light strikes a glass plate at an angle of 60 degrees. Okay. A ray of light strikes a glass plate at an angle of 60 degrees. If the reflected and refracted rays are perpendicular to each other, then the refractive index of the glass is. Simple question, I will tell you, but it's a very good question. Okay. Now see. Let's suppose in this particular question, what does it say? That we have got a surface over here. This is the surface. Okay. Onto this surface, we say, sir, incident ray is falling. This is the incident ray which falls onto the surface. So we say this is what we call incident ray. Okay. Now, my dear friends, listen to me very carefully. I am saying this is the normal. Okay, over here. This is the normal over here. And the questioner says that if the incident ray falls onto the surface, some part of it gets reflected. Let's suppose something like this. Some part of it gets reflected, something like this. And some part of it gets refracted. Let's suppose something like this. Okay. This is the reflected ray. And this one is the refracted ray. Okay. Now, my dear friends, it says that the refractive index of the glass is, what it is saying, a light ray strikes a glass. This is a glass. Let's suppose from the lower side it is glass, from the upper side it is air. Okay. So we say at an angle of 60 degrees. So means angle of incidence in this case is given as 60 degrees. Okay. And my dear friends, we say reflected ray and this refracted ray, both are making the angle of, we say, sir, 90 degrees over here. Both are making the angle of 90 degrees over here, because the questioner says in the question itself. Okay. So the refractive index of the glass is, we are supposed to find the mu of this medium, which is the lower medium. We are supposed to find the mu of this medium. Now, guys, listen to me very carefully. Can you tell me in this particular case, guys, this is the angle of incidence, angle between normal and incident ray. Can I say this will be the angle of reflection, 110%? Angle I is equal to angle R. Now tell me one thing. We said this angle is 90 degrees and this is 60 degrees. How much will be this? This will be 30 degrees. So we say, sir, this is 30 degrees. Okay. Now guys, it is saying that this refracted ray and this refracted ray, both are making the angle of 90 degrees. So means if this is 90, this is 30, how much will be this angle? I can simply say, sir, this angle will be again 60 degrees. Okay. Now guys, once again, I want you guys to focus. Sir, this angle is 90 degrees. This angle is 60 degrees. How much will be this angle? Once again, this angle will be 30 degrees, because 30 plus 60 is 90 degrees. So this is the refracted angle. I'll write over here. Refracted angle or angle of refraction. And this is the angle of reflection. Okay. Now, my dear friends, listen to me very, very, very carefully over here. Can we use the Snell's law? We can use the Snell's law. This is the one medium. This is another medium. When light goes from one medium to another, in that case, we use the Snell's law. So we say use Snell's law. If we use Snell's law. So what does Snell's law say? Mu I into sine of I is equal to mu R into sine of R. That is mu I into sine of I is equal to mu R into, we say, sir, sine of R. Mu I means refractive index of that medium in which incident rays are present. That is mu of this. So we say, sir, this is air. So I can say for air, we write it 1. Sine of I, angle of incidence is 60 degrees. So sine 60 is equal to mu R, that is refractive index of glass. We are supposed to find this one only, mu. Sine of R, angle of refraction we recently got, that is sine 30. So I write sine of 30 degrees over here. Sine of 30 degrees over. Okay. Okay. Now, my dear friends, tell me one thing. Can I say, sir, this will be 1 into sine 60 will be how much? That is root 3 divided by 2. Okay. Root 3 divided by 2 is equal to, we say, mu we are supposed to calculate. And then we say sine 30, it is 1 by 2 over here. So can we say this will be mu is equal to root 3 in this particular case? Mu will be root 3. So refractive index of this medium or glass, this is the glass from lower side, will be root 3. Tell me in the chats, is this crystal and clear? Each and every one, guys, give me the signal, with the fire emojis, Okay, with the fire emojis. Great. Okay. Now, next question we have on the screen. What is that? The question is, if the critical angle for total internal reflection, from medium 1 to vacuum is 30 degrees. So in this case, theta C is given as, we say, sir, 30 degrees. Okay. The velocity of light in that medium is, listen to me very carefully. The questioner says that we have got a medium over here. This is a medium. Okay. We say, let's suppose this is the normal. Okay. Okay. It says that the light goes from, we say this is, let's suppose, some medium, and this is, we say, sir, air. The light goes from this medium to, we say, air. So we are saying this is the light which goes from this medium to, we say, sir, air. To, we say, sir, air. Okay. Now, my dear friends, it is saying that, it is clearly saying that we are supposed to find the critical angle is given over here. Means at, if this is critical angle, the refracted ray will make 90 degrees with the normal. Okay, this is the refracted ray. It will make 90 degrees with the normal. Okay. Now, my dear friends, listen to me very carefully. So this theta c in this case is given as how much? We say, sir, 30 degrees. What we are supposed to calculate is, we have to find what is the speed of light in this medium. What is the speed of light in this medium? That's what we are supposed to calculate in this one. Now tell me one thing. What we can do in this particular case is, I say use Snell's law. Okay. What does Snell's law say? That is, we say, sir, mu I into sine of I. Sine of I is equal to mu2 into mu r into sine of r. Now, what is mu I? In this particular case, that is refractive index of this medium. Okay. So I say this is the medium exactly over here. Okay, we will find the refractive index of this medium. Refractive index of this medium is 1 because it is air. Okay. So we say mu I, I'll write that is mu. Sine of I means, sir, this is the angle of incidence over here, that is theta c, and theta c is given as 30 degrees. So I'll write over here, this is sine of 30 is equal to 1. Refractive index of air is 1. Sine of r, that is 90 degrees. Okay, because this is making the 90 degrees over here. So can I write in this particular case? So it will be mu into 1 by 2 will be equals to 1 into 1. So mu will be equal to 2. So refractive index over here is 2. Now, you guys should know one formula that I have told you before. What is that? Listen to me very carefully. That is, we say speed of light in any medium. Okay, speed of light in any medium is equal to speed of light in air, that is c, divided by, we say, sir, refractive index of that medium. If you have to find the speed of light in any medium, you take the speed of light in air or vacuum or free space and divide it with the refractive index. So I can write this will be 3 into 10 raised power 8 upon. What is the value of refractive index? That is 2 over here. Okay. So we say this will be simply 1.5 into 10 raised power 8 meter per second. So that medium which has the refractive index of 2 will be having how much speed for the light? We say, sir, 1.5 into 10 raised power 8 meter per second. But in the, sir, it is not given 90 degrees. That is the reason I told you to join the marathons. Okay, this I have already discussed. Whenever theta c is given, critical angle is given, the meaning of critical angle itself is refracted ray will make the 90 degrees. This is what we have learned from the theoretical part in the marathon. If any light ray is falling onto any, we say, sir, is moving from one medium to another medium, it is making critical angle theta c. Then we say in that case, refracted ray will make 90 degrees. Guys, like this session if you have not liked this session yet, as soon as possible. Now take a look on this particular question. I want you guys to solve this question from your end. The refractive index of a certain glass is 1.5 for light, where wavelength in vacuum is 6000 angstrom. Okay, the wavelength of this light when it passes through the glass is, let's suppose if we talk about a vacuum, in a vacuum, guys. So it says that refractive index of a glass is 1.5 for light, where wavelength of the vacuum is this one. Okay. Now tell me one thing. If we talk about a vacuum, can we use this formula? We have to find the wavelength of the light in the glass. We have to find lambda in glass. Guys, we say, sir, frequency is c divided by lambda. This is the formula everybody knows. Frequency is c divided by lambda. Now tell me one thing, sir, frequency. C is what? Speed of light. So can I say, sir, this is 3 into 10 raised power 8? And lambda for vacuum. So guys, lambda means wavelength. So wavelength of this light in vacuum is given as how much? We say, sir, 6000 angstrom. So I'll write over here, this is 6000 angstrom. Okay. So you can say frequency will be simply, in this particular case, 1 by 2 into 10 raised power 5. Okay, you got the frequency. Now, if we talk about a medium, if we talk about a medium, listen to me very carefully. I say, in case of a medium, we say, sir, frequency will be, guys, when we talk about vacuum, frequency will be, we say what? Speed of light in air or vacuum divided by wavelength in air. But when we talk about the frequency in a medium, so can I say, we say, sir, this is Vm divided by, we say, sir, lambda m over here. So if we talk about the medium, we say, sir, over here we write speed of light in that medium divided by wavelength in that medium. Okay. Now guys, I have told you speed of light in any medium is, we say, sir, c divided by mu. So I can write over here, this will be c divided by mu into, we say, sir, lambda m, Now guys, frequency is same over here also. We say, this is what I have told you before. Frequency remains the same. So whatever is the frequency in free space, same will be the frequency over here. But wavelength changes. When light moves from one medium to the another medium. Okay, so we say over here, frequency I can write 10 raised power 5 divided by 2 is equal to, we say, sir, speed of light in air is 3 into 10 raised power 8 divided by refractive index. So refractive index of this glass in this case is given as what? We say, sir, 1.5. So I'll write this is 1.5 into lambda m. So from this you can calculate lambda m will come out to be, that is 4000 angstrom. So we were supposed to calculate the wavelength of the light in medium where its refractive index is, we say, sir, 1.5. Is this clear? If you get any sort of confusion in any problem, I request you to guys watch it later once again. Okay. Now, one more question in this case is given over here. What is that? If the frequency is 5 into 10 raised power 16 hertz, if the frequency is given as 5 into 10 raised power 16 hertz, and the speed of light in air is 3 into 10 raised power 8 meter per second. Okay. Find the ratio of wavelength of light in the medium of refractive index to air is. Okay, this is what you are supposed to find. Refractive index, you guys are supposed to tell me the ratio of the wavelength of light in a medium of refractive index 2 divided by air. Okay. Okay, this is what you are supposed to calculate. Tell me one thing, guys. If we talk about wavelength in air, okay, we say, sir, it will be c divided by f. Because we know, sir, f is equal to, we say, sir, c by lambda. F is equal to c by lambda. So instead of lambda, can we say, sir, it is c divided by f, 110%. And if we talk about a medium, so for medium, I can say that is speed of light in that medium divided by frequency. As I told you, frequency remains the same. That's what I'm exactly doing. This is the speed of light in air, that is c. And this one is the speed of light in that medium. This is the speed of light in that medium. Okay. Okay. Yes, sir. Now tell me guys over here. What is that? What you are supposed to tell me in this case? See. In this question, can I say, sir, we have to find lambda of this medium, wavelength of the light in medium divided by wavelength in air. Okay. That will be simply, that is Vm, speed of light in that medium divided by f upon c divided by f. Okay. Okay. So f and f will cancel. So I can simply write over here, this will be Vm divided by c. Let's call this as equation first. Let's call this as equation first. Okay. Now you guys tell me one thing, guys. What is that? As. Have we discussed this? That is V is equal to C divided by mu. Speed of light in any medium is equal to speed of light in air divided by refractive index. Yes, sir, we have discussed this. So can I say, sir, this will be Vm divided by C is equal to 1 divided by mu? Yes. Now this is equation second. Now can you take a look at equation first? And can you take a look at equation second? 110%. So we say over here, Vm divided by C is equal to lambda medium divided by lambda air. Here, Vm divided by C is equal to 1 by mu. So can I say, sir, from first and second, what we can write? I can write lambda medium divided by lambda air will be simply 1 divided by mu. 1 divided by mu. And what is the value of mu over here? Mu in this case is given as of the refractive index 2. So let's put over here, that will be 1 by 2. And this was the ratio that we were supposed to calculate in this particular question. I hope you guys got it. Let me know in the chats, guys, if this is crystal and clear to each and everyone, everybody out there. Next question we have got over here. Is this crystal and clear to each and everyone, guys? Let me know in the chats. Let me know in the chats with the fire emojis. And guys, if you have not liked this session yet, I want you guys to like it as soon as possible, because liking this session is mandatory. Hey, what are you guys doing in the chats? Fan association. What is that? Focus on the studies, huh? Focus on the questions, follow the questions. Okay, great. Now, in this particular case, a monochromatic light is incident at a certain angle on an equivalent triangle prism. Okay, that's what we call the equilateral prism. And suffers a minimum deviation. If the refractive index of the material of the prism is √3, then the angle of incidence is. Okay. So we are basically, this is the question on the prism. Okay. We have already discussed the prism. Okay. Let's suppose this is the prism over here. Okay. And light falls onto the prism. Okay. And we know, sir, when the light falls onto the prism, it gets deviated something like this. And then after refraction, once again, it moves something like this. Okay. And in this particular case, we are supposed to find the value of angle of incidence. This I we are supposed to calculate. Now, guys, listen to me very carefully. What is given in the question? In the question it is given that it is an equilateral prism. So equilateral prism means this is the angle of prism. Means A in this case is given as 60 degrees. So clearly A in this case is given as 60 degrees. Yes, sir. And we say, sir, it is showing the minimum deviation. This is what we call the deviation. Okay. How much is the deviation from? How much is the deviation of incident ray and final ray? How much is the angle between incident ray and final ray? Okay. So guys, we have studied, sir, when it comes to the minimum deviation, what is the formula for minimum deviation? That is 2I minus A. 2I minus A. Okay. Now, my dear friends, in this particular case, it says that if the refractive index of the material, this material has got the refractive index √3, is given as √3. Okay. Okay. And a monochromatic light incident on an equilateral prism suffers the minimum deviation. Okay. And if the, okay, fine. We are supposed to find the angle of incidence. In this case, we have to find the angle of incidence. Okay. We have to find the angle of incidence. Let me tell you over here. Guys, listen to me very carefully. What we can do in this particular case is, if you take a look on this one, we say, sir, this is what we call the incident ray. Okay. This is what we call the refracted ray. And this is the surface S1. This will be the normal. And this angle is what we call the angle of refraction. That is the R1, angle of refraction R1. Okay. Now in this particular case, guys, first and the foremost thing, you guys tell me, can you tell me what is the value of this angle of refraction over here? So we can clearly say, see, this is R1, angle of refraction over here. Listen to me very carefully. Guys, when it says that minimum deviation, listen to me very carefully. When it comes to the minimum deviation, in case of minimum deviation, this is the concept we have studied. This is the concept we have studied in the marathon. In case of minimum deviation, we say, sir, this minimum deviation used to be, we say, sir, 2i minus a. Okay, this was a minimum deviation. And we used to say, sir, this r is simply a divided by 2. If you have to find the angle of refraction in that case, this r, we say, sir, it will be a divided by 2. Because we have discussed this. In case of minimum deviation, R1 is equal to R2. Sir, what is R1? Guys. This angle is over here, R1. And this angle was, we say, sir, R2. This angle was R2. I hope you have joined my marathon session. In that case, we say, if we have got a prism, this is the incident ray which is entering the prism. So this is angle of refraction on surface 1. This is what we say angle of incidence on surface 2. This is the surface 2. And then you have got this angle of emergence. So in case of minimum deviation, over there only I spoke that I told you R1 is equal to R2. So we can say, sir, angle of refraction will be, that is 60 by 2, that is 30 degrees. So R is given, angle of refraction R1 is given as 30 degrees. Okay. Now, my dear friends, we say apply Snell's law on S1. On this surface S1, apply Snell's law. What does it say? Sir, mu I into sine of I is equal to mu R into sine of R. Sir, what is the value of mu I? We say, sir, value of mu I in this case is 1 because the light is moving from air to glass. Okay. And then sine of I we are supposed to calculate is equal to, sir, refractive index of this prism, that is how much? We say, sir, that is given as a √3 over here. Okay. And then sine of, we say, sir, 30 degrees because R came out to be 30 degrees. So we say, sir, sine of I is equal to √3, sine 30 is 1 by 2. So this is √3 by 2. So I in this case will be 60 degrees. I in this case will be 60 degrees. So this angle of incidence in this case comes out to be 60 degrees. I hope you guys got the approach what I was trying to say in this particular case. If not, please repeat it later on. Once again, watch it at 2x. You'll get to understand that. Okay. Is this crystalline clear? Let me know in the chats. Is this crystalline clear? Is this crystalline clear? Yes, we'll do the videos on the very important topics. Don't worry about that. Chill. Okay, now listen to me very carefully. Yes, class 11th marathon is coming. Okay, that will be scheduled on the channel. We'll teach you that also. Okay, now listen to me very carefully. This is the question that we have exactly over here. The ratio of the intensities of two waves is 25:1. Okay, they are producing the interference pattern. The ratio of maximum and minimum intensities are, okay. Here, I want you guys to remember one single formula. Listen to me very carefully. Remember this formula. What is the formula? I'll tell you. What is the formula? I'll tell you. See. We say, what is the formula? I'll tell you. See. We say, sir, I max maximum intensity upon I minimum. It is equal to, we say under root of I1, okay, under root of I1 plus we say under root of I2, okay, whole square divided by, this is under root of I1 minus under root of I2 whole square. If you have got the two waves, let's suppose, and you are supposed to find the maximum intensity, you are supposed to find the minimum intensity. Guys, listen to me very carefully. You have got the two waves. The intensity of first wave is I1, intensity of second wave is I2. Now you are supposed to calculate the maximum intensity and you are supposed to find the minimum intensity when they interfere. So this will be the formula in that case. So directly you have to remember this. Now see. So we say, it is saying in the question that the ratio of the intensities of two waves is 25:1. Let's suppose first wave has got the intensity I1. Listen to me very carefully. So ratio is given in this case as 25:1. Can I say the ratio is 25:1 only if I say I1 in this case will be 25 times of I0? Yes, sir. So means I2 in this case I'll put as I0. Then only ratio will come out to be I1 is to I2 will then only come out to be 25:1. So means the value of I1 in this case is 25. Value of I2 is, we say, sir, I0. Then only ratio will come out to be 25:1. Okay. Now what we are supposed to find? Maximum intensity by minimum intensity. So what is the formula? Formula we know over here. Now put the values in the formula. So I can write I maximum divided by, we say, sir, I minimum is equal to, what is the value of I1 in this case? That is 25 I0. So I can simply write over here that is under root of 25, and we say, sir, in this particular case that is I0. Okay. And then we say minus under root I0, this is I2, its whole square, upon, we say, sir, this will be under root of 25 I0. Then we say minus, we say, sir, I0 over here, and then we say, sir, whole square. So guys, if you solve it, it will come out to be, further I'll write over here, it will come out to be, we say, sir, 6 under root of I0 divided by whole square. Okay. And then it will be 4 under root of I0 and it will be whole square. Okay. So my dear friends, further you can write it. So this will be 36. 6 square is 36. 36 I0 divided by, I can write 16 I0. So I can write I0 will get cancelled. So this will be 9 divided by 4. 9 divided by 4. So the ratio of maximum to minimum intensity is what? We say 9:4. 9 divided by 4. Is this clear? Is this clear? Is this clear? Okay, so what is given in the question, guys? If you have got the two waves, okay, this is the question from the wave optics. If you have got the two waves, one is having the intensity I1, another is having the intensity I2. And if they ask you to find the maximum intensity divided by minimum intensity, use this formula. Okay, that's it. Next question we have got over here, that is two monochromatic light waves of amplitudes A and 2A. Okay, we have got the two waves over here having the amplitude A and 2A interfering at point. They are interfering at point, have a phase difference of 60 degrees. The intensity at that point will be proportional to. Now see, guys, we have got the two waves. Okay, we say in this particular case A1 is given as A, amplitude of the first wave is given as A, okay, and amplitude of A2 is given as 2A. This is the second wave has got the amplitude 2A. Okay, now guys, can we find the resultant amplitude? We say, sir, A resultant in this case will be under root of, we know, sir, this will be A1 square plus A2 square plus twice A1 A2 cos of phi. This is the phase difference between the two. So we say, sir, phi in this case is given as 60 degrees. Phi in this case is given as 60 degrees. Okay. Now tell me one thing. What is that? I can simply say in this particular case, it is under root of, we say A1 square. That is, I would say A square plus A2 is how much? I would say 2A whole square plus. Then we say 2 times of A into 2A, then cos of 60 degrees over here. So I can simply write this will be under root of, this is a square plus 4a square. This is a square plus 4a square. Then we say plus, once again, 4a square. Then cos 60 is 1 by 2. Cos 60 is 1 by 2. Okay, okay. Now tell me one thing. Tell me one thing. Can I write over here? My dear friends, can I write over here? This will be simply, if you solve it, this will come out to be 7a square. Under root of 7a square. Now guys, this is the resultant amplitude. But what we are supposed to find? We say we are supposed to find the intensity. We know as we know. What do we know? We know, sir, intensity is proportional to a square. Intensity is always proportional to the amplitude square. So if intensity is proportional to the amplitude square, so what is the amplitude, resultant amplitude? Under root of 7a square. So can I say I is proportional to under root of 7a square whole square? So intensity is proportional to, this is their a, and it is a square. So intensity is proportional to, we say, sir, 7a square in this case. So intensity is proportional to, we say, sir, 7a square. 7a square. Let's move on to the next one. Okay. The question is given as, if the power of light is 10 kilowatt, okay? Power of light is given as 10 kilowatt. And the wavelength is 300 nanometer. Guys, if you have not liked the session yet, I want you guys to like it as soon as possible. Liking the session is mandatory. So, in the question it says that, if the power of light is 10 kilowatt and wavelength is 300 nanometer, okay? Then find the number of photons per second. Guys, have you studied this particular formula as, we know, sir, power of light is equal to, that is nhc divided by lambda into t, energy per second. nhc by lambda is energy divided by time. Time is second over here. Now, can we do one thing? We have to find the number of photons per second. How do we find the number of photons per second? See, guys, you can get the PDF of this on my Telegram channel, that is t.me/Yawar Manzoor, YAWARMANZOOR. Join this Telegram channel for all the notes, for all the updates, everything, discussions, okay? So I want you guys to join this Telegram channel as soon as possible, okay? Because this is mandatory. I will be sharing each and everything over here only, This is my personal Telegram channel. You can connect with me on this Telegram channel only, okay? Enough. Let's focus on this one. So we have to find the number of photons per second. So what we can do in this case, can I write n divided by t will be? It'll be, that is p into lambda upon hc. So find the value of n by t in this case, that is p into lambda divided by hc. Guys, what is the value of p? What is the value of lambda? Everything is given over here. Power is given as 10 kilowatt. Lambda is given at 300 nanometer. Okay. So we say P, that is 10 raised power 4, 10 kilowatt multiplied by 300 nanometer. So that is 300 into 10 raised power minus 9. Okay. Divided by HC. Value of H is 6.6 into 10 raised power minus 34. Multiplied by C. Value of C is 3 into 10 raised power 8. So if we combine them, so this will come out to be 2 into 10 raised power minus 25. Solve this and you'll get the answer. Okay, that is number of photons per second. Very, very important question that I am showing you right now. Very important question. Very, very important. One of the good questions in the today's session. Okay. The questions are mixed. Okay. The questions are mixed. Okay. Some questions you will get after. This is not like in a particular, we say, sir, order. Like for first chapter it is this, for second chapter it is this. The questions are mixed. Now see, we say when the intensity of light source is increased, the number of photons emitted by the source in unit time increases. Is the option A correct or incorrect? Is the option A correct or incorrect? Tell me, is the option A correct or incorrect? When the intensity of a light source is increased, the number of photons emitted by the source in unit time increases. Is this correct or incorrect? I want you guys to tell me the answer. Guys, see. As when it comes to the intensity, we say, sir, intensity is equal to NHC divided by lambda AT. Lambda AT. Guys, listen to me very, very, very carefully. This is the formula of intensity. Clearly, we can see over here, intensity is proportional to the number of photons. Intensity is proportional to the number of photons. More the number of photons will fall, more will be the intensity in that case. Yes, sir. Yes, sir. Now, if intensity increases, what will happen to the number of photons? We say number of photons emitted by the source in unit time increases. So option A is correct. Option A is correct because intensity is proportional to the number of photons. Second option, the total energy of the photons emitted per unit time increases. Emitted per unit time increases. The total energy of the photons. Now guys, tell me one thing. We have studied total energy of photons. We have studied total energy of photons. We know, sir, when it comes to the total energy of photons, we say, sir, that will be energy is equal to NHC divided by lambda. This is the total energy of photons. Now, if N is increasing, we say, sir, total energy will increase. So we say option second is also correct. Option second is also correct. Okay. Now, if we talk about the option 3, C, is option C correct or incorrect? More energetic photons are emitted. If we talk about energy of one photon, energy of one photon is H into F or Hc by lambda. Guys, we say energy of photon does not depends upon N, but total energy of photons does depend upon N. Energy of one photon does not depend upon N. So we say option 3 is incorrect. It is saying more energetic photons are emitted, means now the energy of every single photon has been increased. No, if you want to increase the energy of one photon, you have to increase the frequency. If frequency increases, we say energy of photon will increase in that case. Keep that thing in your mind. Okay, so we say this is wrong. Faster photons are emitted. What does faster? Maximum, what is the speed of light? 3 × 10 raised power 8. So that is the maximum. So this is option. Option D is also incorrect. Okay. Okay, then we have one more question over here on the screen. Take a look at this question and tell me the answer of this question. Light of frequency is 1.5 times. Light of frequency is 1.5 times the threshold frequency. Light of frequency 1.5 times the threshold frequency, means frequency of light in this case is given as 1.5 times of f naught. What is the threshold frequency? Threshold frequency is that frequency. Threshold frequency is that frequency at which photoelectric effect takes place. Okay, so photoelectric effect will take place, so photocurrent will be produced. Now it says that on a photosynthesis, if the frequency is halved, it says that if the frequency is halved, means now frequency becomes halved. So what is the half of 1.5? That is 0.75. So now, my dear friends, frequency of this light will be less than. We say, sir, threshold frequency will be less than threshold frequency. So tell me in this case, will the photoelectric effect take place? We say, sir, no photoelectric effect will take place. So means no photocurrent. Hey guys, why? Because I am saying that this threshold frequency is that value of frequency at which photoelectric effect takes place. Now, if you are sending the incident photons which have got the less frequency than this one, so how is it possible that the photoelectric effect will take place? So we say in this case, photocurrent will be 0. No photocurrent. Okay, then the photocurrent would become 0 in that case. Okay, an important question over here. Take a look at this particular question. The question is, an electron of mass m When accelerated through a potential difference V, an electron of mass m, when accelerated through a potential difference V, has wavelength lambda, okay, then the de Broglie wavelength associated with a proton of mass capital M through the same potential difference will be, okay. Let me show you this question. Let me show you this question. It's a good question actually. Guys, if you have not liked the session yet, I want you guys to like it as soon as possible because that is mandatory. Everybody out there, everybody means everybody. Okay, everybody. Everyone means everyone. Like the session, guys. Make the like count 1 lakh plus right now. Right now means right now. When will you start a Sathana Butta? When will I will teach you the important topics also. That's for sure. Okay, but right now you focus on this particular this chapter. Okay, this particular session. I'll be teaching you those important topics also. Don't worry about that. Chill. Hmm? Okay. Now, in this question, what does the questioner say? What does the questioner say? I'll tell you over here. Guys, see, when a particle is accelerated under potential difference, how much is its wavelength? We say, sir, its de Broglie wavelength is h upon, we say, sir, under root of 2mq delta v. If you have a charge which is accelerated under potential difference delta v, its de Broglie wavelength is this much. Delta V is that potential difference, Q is the charge, okay, M is the mass, and H is Planck's constant, okay. Now, my dear friends, listen to me very carefully. If we talk about for an electron, if we are talking about an electron, can I say, for an electron, we say, sir, de Broglie wavelength will be H upon, which is accelerated under potential difference delta V, H upon, we say, sir, under root of 2m, mass of electron is m, and charge on an electron is E, Q, instead of Q I write E, delta V, that is given as V, potential difference given as V. Similarly, if I say over here, that is for a proton, can you tell me what will be the de Broglie wavelength? You say, sir, simply it will be lambda for proton is H upon under root of 2. What is the mass of the proton given in the question? That is capital M. Okay, 2m, and charge on a proton is also E, and potential difference is also V, that is same. Now, what we are supposed to calculate in this case is we have to find that is lambda E divided by lambda P over here. We are supposed to find the de Broglie wavelength associated with a proton of mass m through the same potential difference will be, and mass of, okay, mass of this is this. Okay. Now see, we are supposed to find the de Broglie wavelength of the proton. Okay, de Broglie wavelength of electron is given as lambda E, and which is given in the lambda. Now tell me one thing. So can I write over here, sir, what is lambda E? Lambda E is this one. So I'll copy it as it is, duplicate, and I'll place it over here. Then divided by, and then lambda of proton is this much. I'll copy it and I'll paste it over here, this one. Okay. Now, my dear friends, can I cancel this H and H? 2 and 2, E and E, V and V. What remains? Root small m, root capital M. So I can write it, this will be under root of capital M divided by under root of small m. I can write it something like this. Now guys, listen to me very carefully. We are supposed to find this lambda P. So can I say, sir, lambda P will be lambda E under root of capital M divided by small m? Yes, sir. And what is lambda E? It is given in the question. For electron, wavelength is given as lambda. So I can write lambda P is equal to, we say, sir, lambda under root of capital M divided by small m. Lambda under root of capital M divided by small m. Option D. Okay. Okay, is this clear? Hey guys, see, this is over here 1 by root small m, and then it is 1 by root capital M. If you do the reciprocal, it will be root capital M by root small m. Now, finally, you are supposed to find what? See, you are supposed to find lambda p. Take this lambda p over there and take this lambda m over here and do the reciprocal over here. Okay. Tell me. Okay. Yes. Option B. Yeah. I made a mistake. Directly, I'll write over here, this one. Okay. Yes. Now, my dear friends, let's move on to the next one. This was the question which was asked in. Yes, it's correct now. Now, which was the question? This was the question which was asked in VC Sir NEET 2016 and IIT JEE 2021. I want you guys to solve this question over here only. So, and this question is exactly like the upper question. Okay, this question is exactly like the upper question. Now tell me one thing in this particular case. Question is asked on the same concept. The question is asked on the same concept. That is, an electron of mass m and a photon have the same energy E. Okay. Now guys, listen to me very carefully. Very carefully. Okay. See. I'm saying that in this particular case, hey, is the upper one cleared? I made a mistake over here. This was simply lambda, this one. Option B, small m by capital M. Okay. Lambda E is equal to lambda into under root of m by this m. This option. Okay. Just the cross multiply over here. Take it over there in the numerator and take this over there. You just have to do the cross multiply. Okay. Now see. So we are given in this case an electron and a photon have the same energy E, in the range of few electron volts. Okay. In this particular question, what is given is that, listen to me very carefully. We are given a photon. Okay, guys. And can you tell me how to find the energy of the photon? Don't say, sir, we know, sir, energy of a photon is simply hc divided by lambda. Okay. What is this? Lambda is the wavelength over here. Can you tell me how much is this lambda? You say, sir, this lambda of photon will be simply hc divided by E. Okay, we got it for the photon. Now see, when it comes to, we say, sir, electron. Now, if we talk about an electron, can you tell me how to find the de Broglie wavelength of an electron? Sir, we know when it comes to the de Broglie wavelength of an electron, in terms of kinetic energy, it is simply lambda E is equal to h upon under root of 2mke. Yes, sir. If you have got an electron or if you have got a particle, you are supposed to find its de Broglie wavelength. You say h upon 2mke. And can I write this will be h upon under root of 2m into E. See, in this case, an electron is given. See, I'll read the question now. An electron of mass m and a photon have the same energy E. Both have the same energy E. The ratio of the de Broglie wavelength associated with the electron. You have to find the ratio of the de Broglie wavelength of an electron and the wavelength of the photon. Lambda E divided by lambda P, that is what you are supposed to calculate in this particular question. Okay. Now tell me one thing. Can we say, sir, I can simply write over here lambda E divided by lambda P will be. What is the value of lambda E? So recently we calculated this is the value of lambda E. I'll take the duplicate and place it over here. And then we said divided by. What is the value of lambda P? This one. Take the duplicate, divide it over here. Okay, okay, okay. Now in this particular case, can I cancel this h and h over here? So what I can write it something like this. See, take this e in the numerator, this will be e upon, then we say under root of, we say sir 2m into e, and then it will be c, 1 by c over here. Now guys, listen to me very carefully, because c over here is in the over here. Okay, you have to take this in the numerator. After reshuffling, it will be something like this. Now do one thing. I want you guys to rationalize. Multiply with root e and divide with root e. Multiply with root e and divide with root e. Now see, this root e and this root e into root e is e. That e will get cancelled with this e. So finally I can write lambda e divided by lambda p will be, in the numerator it will be root of e upon, and in the denominator it will be c under root of 2m, because this root e into this root e is e, that will be cancelled with this e. So I can write it something like this, 1 by c, that is e divided by 2m whole raised power 1 by 2, because value of root is 1 by 2. Now can you check the option, which option it is matching? E by 2m. I guess option A is matching. Option A is matching over here. This was the question which was asked in 2016 NEET and IIT also. One more question. The wavelength lambda e of an electron and a photon has the same energy are related by. You are supposed to answer this particular question. See. In this case, we are given an electron and a photon once again. We are supposed to say they are related with each other. The wavelengths lambda e of an electron and lambda p of a photon of same energy E are related by. Now listen to me very carefully. Listen to me very carefully, my dear NEET aspirants. See, in this particular case, we are given an electron. For an electron, okay, can we say, sir, lambda E is simply h upon under root of 2m into E. This is the wavelength for an electron, okay. And we say, sir, for a photon, I can simply say, if we talk about a photon, I can simply say, sir, it is lambda p is given as, that is hc divided by hc divided by E. So for a photon, I already told you how do we calculate the wavelength. Okay, just do one thing. What is that? Put a root over here and put a root from this side also. Okay. Take root on both sides. We can do it. Why do we have to do it? Because we have to cancel the energy over here. Okay. Now, my dear friends, in this particular case, listen to me very carefully. We say over here, can I say in this particular case, if we just divide, this is equation first and this is equation second. So we say divide equation first by equation second. So we can write, sir, lambda E upon under root of lambda P will be equal to, sir, lambda E is this one. So I'll take its duplicate over here and divide. And then we have lambda photon is over here. I'll take its duplicate and divide over here. Now tell me, in this particular case, guys, this energy and this energy, this is root E, they'll cancel out. And this H is Planck's constant. This is constant. C is constant. M is constant. And 2 is constant. So means I can say lambda E divided by under root of lambda P is constant. Now, a lot of you guys might be having the question over here, sir, why did I put the root in this case? Because I wanted to cancel this root E with this root E, because over here you have got root E. They have the same energy because I need to cancel this energy. So that's the reason I need to put the root over here. Rest all the terms mentioned over here and here are constants. So I can say it's constant. So if this is constant, can I say lambda E is proportional to under root of lambda P? So which option? Lambda E is proportional to root of P. Okay, this one, because it has taken the square over there. Take instead of this square, instead of this root, if you place it over here, it will be lambda P is equal to square of lambda E whole square. Is this clear? Tell me in the chats, everybody out there, is this crystalline clear? Guys, with the fire emojis, and like this session as soon as possible, because that's mandatory. Liking the session is mandatory. Everybody out there. Now see, listen to me very, very, very carefully. See. Figure shows, this is one of the important top questions of today's session. Figure shows 4 situations in which an electron is moving in electric and magnetic field, in which case de Broglie wavelength is increasing. You are supposed to tell me in which of the following cases de Broglie wavelength is increasing. Guys, what is the general formula of de Broglie wavelength? Lambda is equal to h upon m into v. Okay. Now guys, if I say mass is constant and h is already constant, so we say lambda is inversely proportional to the velocity. So if velocity increases, we say de Broglie wavelength will decrease in that case. So if velocity increases, de Broglie wavelength will increase in that. If velocity decreases, de Broglie wavelength increases. If velocity decreases, de Broglie wavelength increases. Now see, listen to me very carefully. In the first case, this one, we have got an electric field. And in this electric field, you have placed a charge. This is an electron. Whenever you place an electron in the electric field, we say it is, let's suppose electron is moving in this direction. We say force will act on it in the opposite direction. Force acts on it in the opposite direction. If force is acting on the velocity in opposite direction, we say its velocity will decrease. Here velocity will decrease. And if velocity decreases, we say, sir, lambda will increase. We say lambda is increasing. Why? Because lambda is inversely proportional to the velocity. Okay, now come over here, option B. Here you have got the electric field. And in this electric field, this is we say, sir, force is acting. I made a mistake over here. As electric field is in the backward direction. Electric field in this case is in the backward direction. Okay, now see. Listen to me very carefully, my dear friends. You have got an electric field in the backward direction. This is the velocity of the electron. Velocity is in the opposite direction. My dear friends, if you have electric field over here, listen to me very carefully. Sir, force acts on this in the opposite direction of electric field. Now it is correct. Previously I made the mistake. Now it is correct. So force and velocity are in the same direction. So means if you have got a body, okay, you are pushing this body, so its velocity is in this direction. So its velocity will increase. So we say here velocity increases. So lambda in this case will decrease. Okay. Lambda in this case will decrease. So we say we are supposed to find that case in which de Broglie wavelength of the electron is increasing. So here lambda is decreasing. So this is not the case. Let's talk about the option B. So in option B, guys, you have got this electron. And on this electron, velocity is in this direction towards right. So electric field is also towards right. Because of this electric field, force will act on it in opposite direction. Now here, velocity will decrease and lambda will increase. So this is the option which we need. Now option 3, let's talk about the option 3 also. Here you have got the magnetic field and you have this charge which is moving in the same direction of magnetic field. Can you tell me here, what is the angle between velocity and magnetic field? We say, sir, theta is equal to 0 degree. Angle between velocity and magnetic field in this case is 0 degree. So whenever the angle between the velocity and magnetic field is 0, force, magnetic force is, that is QVB sine of 0, QVB sine theta. So this is the force over here. Force on the charged particle in magnetic field is this one, if it is moving with velocity v. Sine 0 is 0, so force in this case is 0. If force in this case is 0, my dear friends, we say, sir, velocity will remain constant. If velocity remains constant, we say, sir, lambda will remain constant. But we have to find that case in which lambda is increasing. Here also, here in this particular case, we say, sir, here in this particular case, we say, sir, here in this particular case, we say, sir, theta is equal to 180 degrees. So we say force in this case will be QVB sine of 180 degrees. So here also force is 0. So lambda will remain constant. So this is also not our option. Okay. So option B is the correct option over here. Tell me in the chats how many of you like this particular question. Everybody out there. Let me know in the chats. And guys, I hope you have liked this particular session.
Will change your life.
This app will not change my life. Okay. This was the ad. Let me know. Guys, make the like count 400. Okay, it's 497. I want you guys to make it 600 plus right now. Everybody out there. Okay. Guys, tell me in the chats, is this crystalline clear? Is this crystalline clear to each and everyone? Is this crystalline clear to each and everyone? Okay. Now, guys, let's move on to the next question, which was asked in NEET J Mains 2021. J Mains 2021. Okay. See, the ratio of the speed of the electron in third orbit of hydrogen to the speed of the electron in the third orbit of the of helium. It's not hydrogen, it is helium. Of helium to the speed of the electron in the third orbit of the hydrogen atom will be. Okay, now see. I have told you before that if an electron is revolving in the nth orbit, how much speed does it have? We say, sir, V is equal to V naught Z by N. Okay. This is the speed of an electron in nth orbit. So I can say V is proportional to Z by N. V is proportional to Z by N. Now, my dear friends, listen to me very carefully. I say, if you have got a hydrogen or if you have got a helium, what is the atomic number of helium? That is 2. What is the atomic number of hydrogen? We say 1. Okay. And it is talking about, we say, sir, third orbit. Okay. So means, my dear friends, if we say or I'll just directly write over here. So I'll write, sir, V1 divided by V2. Okay, that is speed of an electron in helium, that is V1. Speed of an electron in hydrogen is, let's suppose, V2. So I can write it will be Z1 by N1 upon Z2 divided by N2 over here. Simple as that. Okay, so I can say, sir, V1 divided by V2 will be Z1 by N1, Z1 by N1 into N2 divided by Z2, N2 divided by Z2. Now, what is the value of Z1? Listen to me very carefully. Guys, if we are talking about the helium, what is the value of Z1? See, this is helium, this is helium, this is helium. So we say Z1 in this case will be Z1 in this case will be Z2 upon. And N1 in this case will be N1 in this case will be what? We say, sir, N1 in this case will be, we say, sir, we say 3, 2 divided by 3, because the orbit is 3 multiplied by, we say, sir, it is 3 divided by 1, 3 divided by 1. Because, see, guys, V1 is the speed of an electron in helium in its third orbit. V2 is the speed of an electron in hydrogen in its third orbit. Just putting the values, 3 and 3 will cancel. So 2 is to 1. 2 is to 1. 2 is to 1. Is that clear? Is that clear? Is that clear? Is that clear? So ratio is 2 is to 1. Let's move on to the next one. Let's move on to the next one. Okay. A mass at rest explodes suddenly in M1 is to M2. So we have got a mass over here, okay? And this mass basically explodes, okay, into M1 and M2. Let's suppose this is M1 and this is M2. The mass M basically explodes in M1 is to M2. Okay, and we are supposed to find the ratio of de Broglie wavelength. Guys, everybody knows that the case of explosion, everything and all, in all of these cases, we say, sir, momentum remains conserved, momentum remains constant. Okay, so directly, when you have the case of explosion, mass basically explodes, means the momentum initial is equal to the momentum final. So momentum remains constant. We are supposed to find the ratio of the wavelength, that is lambda 1 divided by lambda 2. Okay, so we say lambda 1 by lambda 2 is simply as we say, sir, lambda is equal to h divided by p. Can I say h is constant, p is constant, so it remains constant. So lambda 1 by lambda 2 is 1 by 1, that is 1 is to 1. Simply direct concept we will be using over here. Yes, an important question was asked in JEE mains 2021. Question was asked in JEE mains 2021. In a Bohr's atomic model of hydrogen, kinetic energy and total, let K, P and E be the kinetic energy, total energy and potential energy of the electron respectively. Choose the correct option. Okay. Guys, tell me one thing. Do you guys know that in an atom, the kinetic energy of an electron is equal to, we say, sir, kinetic energy is equal to, we say, sir, equal to, we say simply, listen to me very carefully, we say minus ZE square divided by R. And after that, one more equation I have told you in the last class. What is that? I'll show you over here. Sir, when it comes to the total energy, when it comes to the energy of an electron in the nth orbit, we say, sir, that is minus 13.6 Z square by N square. I hope you remember this formula. This is what I told you in the last class. Energy of an electron in the nth orbit of hydrogen atom. If an electron is revolving in the nth orbit of hydrogen atom, its energy is minus 13.6 Z square by N square. So we say energy is, this is total energy is proportional to, inversely proportional to minus 1 by N square. Okay, since we are talking about the hydrogen, for hydrogen Z is equal to 1. Similarly, I told you, sir, kinetic energy is inversely proportional to N square. Kinetic energy is just the positive of total energy. If it is negative, it is positive. Kinetic energy, I told you, sir, that is 13.6 divided by n square only for hydrogen atom. And potential energy is also minus 1 by n square. It is also inversely proportional to minus 1 by n square. Directly, you guys remember it, okay? Total energy is this one. Total energy is inversely proportional to negative of 1 by n square. And this is positive and this is negative. Now tell me one thing. Now tell me one thing. Listen to me very carefully. In the question, it says that choose the correct option when electron undergoes the transition to the higher level. When electron goes to the higher level means n is increasing. For first orbit, n is 1. For second orbit, we say n is 2. As you keep on increasing the n means you are moving into the higher orbits. Now tell me one thing, guys. Listen to me very carefully. This is a good question. We say if n is increasing, total energy is inversely proportional to n square. We say total energy will decrease. Now guys, total energy will decrease, but it is negative. It is decreasing in negative. Now my dear friends, if I say minus 13, minus 14, which is bigger? We say over here, this is bigger, minus 13. Okay, same is the case in this particular question. We say, sir, total energy is inversely proportional to n square. So if n square increases, if n increases, we say, sir, total energy decreases. So if total energy decreases, my dear friends, but it is decreasing in, we say, sir, it is minus in negative sign. So decreasing in negative sign means total energy is increasing. So we say total energy increases. Total energy increases. Same will be in case of potential energy. So potential energy will increase. But in case of kinetic energy, we say, sir, kinetic energy will decrease. So which option? Option number B. Okay, next question we have got over here. This was also the question which was asked in J Mains 2021. An electron moving with a speed v and a photon moving with a speed c. An electron moving with a speed v and a photon moving with a speed c have the same de Broglie wavelength. The ratio of energy of electron to that of the photon. To that of the photon. Listen, listen, listen. See, guys, in this case, it is saying that we have got an electron and a photon, both have the same de Broglie wavelength. Means de Broglie wavelength of electron is equal to the de Broglie wavelength of photon. Okay. And when we talk about the de Broglie wavelength of electron, guys, we say, sir, it is h divided by mv. Okay. Is equal to. And when it comes to the de Broglie wavelength of the photon, guys, I have told you, sir, energy of photon is hc divided by lambda. So lambda will be hc divided by E. So can I write over here? Can I write over here? This will be hc divided by E. hc divided by E. Okay. Now, in this particular case, listen to me very carefully. This is energy of photon. Let's call this as equation number first. Okay. Okay. Now, guys, tell me one thing. If we can we write it something like this as for an electron, we can write, sir, kinetic energy of electron or energy of an electron, which is moving with the speed v, its mass is m, it will be 1 by 2 mv square. Guys, see, we are given an electron moving with speed v and a photon moving with speed c, speed of light, have the same de Broglie wavelength. The ratio of kinetic energies of electron and photon, we have to find the ratio of kinetic energy. What I did is, sir, both have got same de Broglie wavelength, just put the equations. Then it is saying that electron is moving with a speed v, so it will have the kinetic energy 1 by 2 mv square. Now, can I write over here? Can I write over here one concept? That is, take this 2 and multiply over here, so it will be 2 times of energy of electron, okay, divided by v is equal to mv over here, because I took 1v and divided over here, so mv is equal to 2e divided by this. Now put in equation first. I want you guys to put this in equation first. Mv, put this mv over here, so I can write now simply, that is we say, sir, h divided by, Instead of mv, I can write 2ee divided by v is equal to hc divided by ep, energy of photon. hc divided by ep, that is energy of photon. Now this h and this h will get cancelled out over here. Okay, we can write energy of electron divided by energy of photon is equal to v divided by 2c. Okay, energy of electron divided by energy of photon is v divided by 2c. So v divided by 2c, option c. Is this clear? Let me know in the chats, everybody. Out there. Before this, I want you guys to solve this question. Solve this question first. Mn and Mp represents the mass of neutron and proton respectively. An element of mass M has n number of neutrons and Z, then the correct relation would be. Guys, tell me one thing. I have told you before, that is, if we have got a mass over here, okay, if we have got a nucleus over here, let's suppose this is a nucleus, and in this nucleus we say sir, m number of protons are there, n number of neutrons are there. Okay, yes, okay, and listen to me very carefully. An element having mass m, n number of protons, okay, z number of protons, sorry, we say z number of protons and n number of neutrons, and it is saying that its mass is capital M. Okay, now if we break this, listen to me very carefully, we will be taking these z protons out, we will be taking these n neutrons out. Yes sir, z protons and n neutrons are in the nucleus. If we break this, z proton is out, n neutron is out. Okay, plus now z protons have got how much mass? See, in the question it says that Mn represents the mass of neutron. So 2 neutrons has got 2n and Mn. Z has got, n has got nmn, like this. N neutrons have got n into, we say, Mn. Z protons have got how much mass? That is Z into Mp. That is mass of Z protons, mass of n neutrons, and collective mass is M. And I have told you before, guys, whenever you break the nucleus, you supply the energy, and that energy is stored in the form of mass. So individual mass, if I write Zmp plus Nmn, is greater than, we say sir, collective mass, is greater than collective mass. Now check which option is correct over here. This is the concept which I have told you in the binding energy. So M is less than Nmn, Zmp, option 4. This is what I have told you in the concept with binding energy. Now come over here in this question. In this question it says that we have got a nucleus, okay. Binding energy, it's okay, cool. Let me show you over here. Guys, listen to me very carefully. Let's suppose if you have got a nucleus over here, okay. Its mass number is A, its atomic number is Z, okay, and its collective mass is M. Okay. Now, if you are breaking this particular nucleus, all these concepts have been discussed in the marathon session. Okay, if you break this nucleus, we say, sir, you'll take these protons out. Okay, sorry, these protons out and neutrons out. Mass number means number of protons plus number of neutrons. So guys, listen to me very carefully. Can I say in this case, sir, Z protons if I take out, so Z protons have got mass Z into MP. Okay, and then we say plus. Guys, if I say this nucleus has got a mass number, Z is the number of protons, like this is the nucleus. 10 protons are over here, 10 neutrons are over here. What is the mass number? We say 20. 20. Why? Because 10 plus 10 is 20. What is the atomic number? Atomic number in this case will be number of protons, that is 10 only. And what is the number of neutrons? Number of neutrons in this case will be, sir, total minus protons, that is 20 minus 10, that is 10. Same concept I'll use over here. Sir, how many number of protons are over there? Neutrons are over there. You say, sir, A minus Z. Total minus number of protons, that is A minus Z. And these many number of protons will be in there, and mass of neutron will be Mn. So this is the individual mass. Sir, can I say after breaking the nucleus, the energy you are supplying will be stored as mass, and that will be greater than the collective mass. That will be greater than the collective mass. Now, I have told you before, if you remember the concepts, I have told you before, if you remember the concepts. Sir, what is that? I have told you, sir. So, if somebody asks you, find the mass defect, how much mass difference came? You say, sir, mass defect in that case will be ZMP plus A minus Z into Mn minus capital M. So larger mass minus smaller mass, that will be mass defect. Okay. Then if somebody asks you, find the value of binding energy, you say, sir, binding energy will be simply delta M into C square. Energy stored in this much of mass. That is delta M into C square. Can I write this? Binding energy will be delta M is how much? That is ZMP plus A minus ZMN minus, we say, sir, M into, we say, sir, C square. Now, what I want you guys to do in this particular case is, I want you guys to take this C square, CC. I will copy this entire term over here, duplicate, but take this C square and divide over here. Take this C square, divide over here. Binding energy divided by C square is ZMP plus A minus ZMN minus M. And this is the answer of this particular question. You can read the theory. So we say, sir, mass of this nucleus will be simply, okay. Binding energy divided by C square. Binding energy plus. Okay. We are supposed to find the mass. See, what we can do, we are supposed to find the mass in this case. We are supposed to find this mass. Okay, take this mass over here and take this binding energy divided by C square over there. Okay, as simple as that, and you will get the value of mass in this particular case. So that mass M will be simply that is ZMP plus A minus ZMN minus BE divided by C square. Option C I am getting over here. Check it later on from your end. Option C I am getting over here. Check it later on from your end. I hope you got it. Yes, option C is I am getting over here. Okay, this is a very, very important question and very good question. This is already we discussed in the last class in the marathon. Okay, already discussed this one. Okay, and we were supposed to find the net force. I hope you remember this one. Already discussed this question. FFP. Okay. In this case, option B. Guys, I have told you, if you have got two neutrons, if you have got two protons, if you have got a proton and a neutron, we say force between two protons is equal to force between proton and neutron is equal to force between neutron and neutron, because nuclear force is same among all. So option B in this case is correct. You can read out the question and you can answer this particular question also. If the nuclei of mass X and Y are fused together to form the nucleus M, some energy is released. It is saying that if you have a nucleus X plus Y and they are joined to form a nucleus, let's suppose M, okay, you are supposed to say energy is released in this process. You are supposed to say, in this particular case, what has happened to the mass We say, sir, in this particular case, simply x plus y is greater than m. Guys, mass, individual mass, we say is greater than collective mass. This is already what we have discussed. The two nucleus are combined together to form a bigger nucleus. We say in that case, energy is released. Guys, energy is released in the form of mass only, na? So if I say energy is released in this case, means mass has decreased. So we say x plus y is greater than m. Okay, this is the question. Very important question over here. I want you guys to solve this question. Not the homework, just do it here only. I'll come in 1 minute. Okay? Till then you solve this particular question. I'll come in just 1 minute. Till then you solve this particular question. Everybody. Which option is correct over here? Which option is correct over here? Tell me in the chats, everybody. Tell me in the chats, everybody. In a nuclear fusion reaction, if the energy is released, then. Guys, I hope you remember one thing. What is that? We say Q is equal to, that is Q value of the reaction is equal to binding energy of products minus binding energy of reactants. Okay. So we used to say, sir, if Q is positive, listen to me very carefully, means energy is released. Okay. And my dear friends, it is saying that in a nuclear fusion reaction, energy is released. Here itself, it is saying energy is released. So energy is released means Q has to be positive. Q value has to be positive. And Q value can be only positive if binding energy of products is greater than binding energy of reactants. Why? If I say this term is 10 and this term is 5, so 10 minus 5 is plus 5. If I say this term is 5, this is 10, 5 minus 10 is minus 5. So we say that's why over here we say binding energy of products has to be greater than binding energy of reactants. Okay, same question over here mentioned also. Okay, just think about it on the same concept, do it later on. Next, okay, this is the question which I will show you in this particular case. The mass of a 3Li7 nucleus is 0.042 U, AMU. Okay, listen to me very carefully. The question says that mass of a 3Li7 nucleus is 0.02042 AMU. less than the sum of all its nucleons. The binding energy per nucleon is nearly. We are supposed to find the binding energy per nucleon in this case. See. First, let me see what is the binding energy. What is the binding energy of this nucleus? Binding energy in this much of mass. You say, sir, binding energy is delta m into c square. And what is delta m over here? Sir, how much see, if I say I have got this much of mass, how much energy is stored in this much of mass? We say delta m into c square. So how much is the mass over here? I can simply say, sir, this is 0.042 AMU and multiplied by, we say, sir, c square. Okay. Guys, one thing I want you guys to remember, this AMU, 1 AMU into c square, we said this is equal to 931.5 MeV, mega electron volts. So remember this from now onwards, okay? You guys have to keep this thing in your mind, okay? Now, I can write over here, this will be simply 0.042. Instead of AMU into c square, I'll write 931.5 MeV. Okay, now guys, instead of 931.5, we consider it, we'll assume it 1000. Let's suppose this is 1000. 1000 into 0.042, it will come out to be 42 MeV. If we are considering this as 1000. So this is the total binding energy in this much of mass, Now, can you tell me how much is the binding energy per nucleon? Now, binding energy per nucleon. What does that mean? That is binding energy in every nucleon, one nucleon. Guys, if we are talking about 3Li7, how many nucleons are over here? 7, because mass number is 7. So I can write binding energy per nucleon. That is 42 divided by 7. 7, this is 6 MeV. This is 6 MeV. Now tell me one thing. So we say in every nucleon, we say if you have to take out every nucleon from the nucleus, how much energy you need to supply? We say, sir, 6 MeV. So is there any option which is matching with 6? No option is matching with 6. But sir, here we have assumed this 931.5 as 1000. So that's the reason you got 6. But if you get the actual answer, that will come out to be 5.6. Whatever is very close to 6, that will be the correct answer. This is the trick that you need to use in your NEET exam. I hope you got this particular trick over here. That is B. The closest to 6 is, we say, sir, B. Okay. This is the next question we have got over here. The binding energy per nucleon in deuterium and helium are 1.1 MeV and 7.0 MeV when two deuterium fuse. Okay, see, what does the question say? The question say in this case is we have got 1H2 plus 1H2. That is when two deuterium nuclei fuse. This is one deuterium. This is another deuterium. 1H2 plus 1H2. It gives you the helium nucleus. That is 2He4 plus, we say, sir, Q. So we say this is helium. These are the two deuteriums. And in this case, this is the Q value of the reaction. Energy absorbed or energy released. And if somebody asks you to find the Q value of the reaction in this case, how do you find? We say, sir, Q value of the reaction is simply binding energy of, we say, sir, reactor products minus binding energy of reactants. As simple as that. Now, in this particular case, this is what we call the product. And in this case, these are the reactants. Tell me one thing. Sir, when it comes to the binding energy of products, see. How many nucleons are over here? We say, sir, 4. In case of products, how many nucleons are there? 4. Here you measure it. This is 4. Okay. So one nucleon, listen to me very carefully. One nucleon of helium has 7.0 mega electron volt binding energy. Okay. One nucleon of helium has 7.0 MeV binding energy. Okay. We say 7 nucleon. How many nucleon? 4 nucleons have got how much energy in this case? We say, sir, 4 into 7 minus, this is the total binding energy of products, minus Binding energy of reactants. In reactants, how many nucleons are there? 2 plus 2 is 4. So we can write over here, this will be 4 into 1 nucleon has got how much binding energy? That is 1.1. 4 into 1.1. So solo it, this will be 28 minus 4.1. So it will be simply 23.6 MeV. 23.6 MeV. So which option? This option. I hope this is clear. Is this clear? I hope this is clear. I hope this is clear. Okay. Let's move on to the next one. Okay, NEET 2017. Which of the following diodes is forward biased? Guys, I have told you before, when it comes to the forward and reverse bias, I have told you before, my dear friends, that see. If let's suppose you have got a PN junction diode, this is P side and this is N side. If P side is connected to higher potential and N side is connected to lower potential, in that case, we say this is nothing but forward bias. In that case, this is what we call the forward bias. Okay. And if N side is connected to higher potential, P side is connected to lower potential, that is reverse bias. Now see over here, which of the following diodes is forward biased? See, this is P side and this is N side. P side is connected to 3 volts. This is lower potential and this is higher potential. So this is reverse bias. Okay. In this case also we say, sir, this is connected to 0 and this is connected to mine. This is forward bias because this is higher potential and this is lower potential. This is -4, -3. This is reverse bias. This is plus, this is also reverse bias. Option B is the correct option. Let's move. Okay. This one you need to, which of the following? Okay, here we have to find which one is the reverse bias. Now see, we say in this particular case, see, this is the diode, something like this. So this is P side and this is N side. N side is connected to -12 volts and P side is connected to -5 volts. This is forward biased. This is forward biased. Okay. And my dear friends, come over here. We say in this case, this is 0 volts because it's earth. So this is minus, this is P side and this is N side. Look at this diode. Look at this diode. So this is also forward biased. Next one, we say, sir, this is 0 volts. This is P side and this is N side. So P side is connected to 0 volts. N side is connected to +5. This is higher potential. This is lower potential. So we say, sir, this will be reverse bias. Next we say, sir, this one, this is P side and this is N side. P side is connected. This is forward biased. I hope this is clear. I hope this is clear. I hope this is clear. Okay. NEET 2016. This question was asked in NEET 2016. In this question, what does they say? What does they say is that two diodes, guys, listen to me very carefully. Two ideal diodes. Two ideal diodes are connected as shown in the figure. Okay, this is the first diode. This is the first diode. This is the second diode. This is the first diode and this is the second diode. This is the first diode and this is the second diode. Okay. Now, guys, listen to me very carefully in this case. It is saying that the current in the circuit of resistance. Okay, we have to find the current in this case. Now, listen to me very carefully. This is the higher potential. This is the lower potential. Higher potential is connected to CCC. In this case, this is, we say, sir, P side and this is, sorry. This is N side and this is P side. This is P side and this is N side. Now see, this higher potential is directly connected to N side and here it is connected to P side. So this is forward bias, this is reverse bias. So I can clearly say this diode in this case will be what? This is reverse bias and this is forward bias. Okay. Now, if I make the net circuit, that will be something like this. See. The battery is over here and Then you have got the 2 ohm resistor. This is the 2 ohm resistor, 2 ohms. And then you have got this. See, when the diode is reverse biased, it is open wire. Open wire. Okay. So remove this, remove this. So this will be over here, this resistance. And this is how much? We say, sir, 2 ohms. This is 10 volts. So current is V divided by R. So how much is V? That is 10. R is 4. So that will be 2.5 ampere. Current is 2.5 ampere. I hope you got it. Next, this was the question which was asked in mains 2012. Can you tell me the answer of this particular question over here? Can you tell me the answer of this particular question over here? See, in this case, you can clearly say that this diode is reverse biased. Okay, I'll say D2 is reverse biased. Why? Because this 5 volt higher potential is connected to P side, N side. Okay, so I can say in this case, current will be I is equal to V divided by R. And V in this case will be how much? V is 5 volts given, okay? And R in this case is how much? R you have to take this one only, because this will behave as open wire. Open wire, because it is reverse biased. So we say 5 by 10, okay, that is 0.5 amp. Option D. Option D. So if simply, if the diode is reverse biased, means it is open wire. Current will not flow through that path. So you have to remove that path from the circuit. Now, in this particular case, tell me over here, find the current through the battery. Find the current through the battery. You have to find the current over here. See. I will tell you. Guys, in this particular case, can you tell me, in this particular case, listen to me very carefully. Find current flowing through the battery. Find current flowing through the battery. You tell me one thing. In this case, we say, sir, this diode and this diode both are forward biased. Why, sir? Because see, clearly. This is the P side and here also it is P side. Both are forward biased. If both are forward biased, now you guys tell me one thing, my dear friends. What is that? Listen to me very carefully. Listen to me very carefully. We say, in this particular case, the resistance is, we say, sir, 10 ohm over here. And if we have to find the current, over here, sir, this diode and this diode, they are connected in series. This resistor is also connected in series. Now, this potential difference will get divided in this, because see, potential difference get divided in series. If I say, sir, we have got 1 resistor, 2 resistor, 3 resistor. Okay, this is, let's suppose 10 ohm, 10 ohm, 10 ohm. Okay, you are connecting a 30 volt battery over here. So we say 10 volt will be across this, 10, 10. Okay, simply. Now, same is the case over here. Sir, in this particular case, you have to tell me how much will be the potential difference across this. See. This is given as the barrier potential. Barrier potential of this diode is how much given? I hope you remember the concepts which I have taught you in the marathons. So barrier potential of this is given as 0.7 volts. So this will take as 0.7 volts. Okay. This will take as 0.3 volts. So 5 minus 0.7 minus 0.3, how much will be remaining? That is 4 volts. 4 volts. So 4 volts will be across resistance. So current will be, sir, V divided by R. So V across resistor is how much? 4 divided by 10. Because resistance is 10. I hope you got it. 4 by 10. Okay. Now in this particular case, guys, this diode is reverse biased. Okay. So current does not flow through this diode. But current will flow through the upper diode, that is forward biased. And my dear friends, see. 5 volt is the battery. You say across this, how much will be the potential difference? 0.3 volts. And how much will be the remaining? Remaining will be 4.7 volts. That will be given to the resistor. Now tell me how much is the current. So I is equal to V divided by R. V in this case is 4.7 divided by, we say, sir, 10. I hope you are loving these questions, okay? Simple logic you have to apply and you will solve the question. Okay, 0.47 ampere. That's nice. Okay. Now. This is the question where you will make the mistake. That is, I guarantee you that you will make the mistake over here. I guarantee you will make the mistake over here. Okay. Now, tell me in this particular case, what will be the value of current? See. Guys, here, this is also forward biased. This is also forward biased. You have to tell me how much will be the current in the circuit. I will tell you. Guys, this potential mentioned over here, what is that? This is what we call the barrier potential. I have told you in case of forward bias, listen to me very carefully. If I make the graph in case of forward bias, current versus this time graph. Now see, my dear friends, we say current versus potential, I versus V graph. Sir, we say the graph in case of forward bias was coming out to be something like this. Let's suppose I am giving a diode over here. Its barrier potential is given as 0.5 volts. Means this will be the barrier potential, that is 0.5 volts. So at barrier potential, you can clearly see, sir, immense number of current is becoming very large. At 0.5 volts. That is what is meaning of the barrier potential. So means if you give the barrier potential over here, so at barrier potential, current will be immensely large. Let's suppose for one more diode. Let's suppose I have got one more diode over here. This is one more diode. Its barrier potential is 0.3 volts. Means when it reaches only 0.3 volts, we say, sir, all the current will flow through this diode only. Now. You are supplying, this is the battery connected to this diode. These two diodes. So we say this diode will reach the barrier potential at 0.5 volts. But this diode will reach the barrier potential only at 0.3 volts. So my dear friends, once you give only 0.3 volts, whole of the current will flow through this diode, because see, at 0.3 volts, current is extremely large. And this diode, through this diode, its barrier potential is 0.5. So we say no current will flow through, because already this diode barrier potential has crossed. All the current will flow through this diode. So we say in this case, current will be V divided by R. V is how much? Sir, we say V is how much? This is taking 0.3 volts. I say, sir, and this is taking how much? We say 5 minus 0.3 divided by R is how much? That is 10. So 5 minus 0.3, so that is 4.7 divided by 10. Ampere will be the current through this. I hope you got the concept, you got the feel of this particular concept. Okay. Next question we have over here. Find the, hey guys, did you get this question? Let me know in the chats, everybody out there. Is this crystalline clear to each and everyone? Let me know in the chats if this is crystalline clear. Find the power loss in the diode if it is ideal diode. Okay. Tell me, guys. Yes. This happens only in parallel combination. Yes. That's the reason over here in case of series combination, I have to take the potential of both the cases. I have to take the potential of both. In case of parallel combination also, we say, sir, we do this. Guys, if anyone is getting any sort of confusion, I request you to guys watch it once again, that question later on at 2x speed. You'll get it. It'll be clear. Let's talk about the power loss. We have got over here AC source. We have a diode. And then we have a resistor. We have to find the power loss. Guys, the formula for power loss in AC, I have told you. What is that? That is, sir, I can simply say, sir, in this particular case, I can say, we say this is EMF V square divided by R. Or we say, sir, EMF square or V square divided by R. Okay, it is one and the same thing. Okay. Now you tell me one thing. You tell me one thing, my dear friends. You tell me one thing, my dear friends. What is that? That is, listen to me very carefully. When we talk about, see. When we talk about the EMF in case of AC source, listen to me very carefully. The formula for, I am saying, you have got an AC source connected to the diode and resistor over here. You have to find how much is the power loss in this case. Sir, we know the formula, power is equal to V square by R. Okay. Now the question is, V, what is the value of V that we need to take over here? V in this case is VRMS. Root mean square value. Directly remember in this case, root mean square value. We say, sir, if I talk about the EMF RMS, or we say EMF means V only, potential difference only, RMS value of EMF. You say that is peak value. Peak value is 10 over here. That is peak value divided by root 2. If you have watched my AC lectures, I have completely told you, if you are given an AC, alternating current, how to find its, we say RMS value. That is I naught peak value divided by root 2. So now put this over here. We can say this power loss will be EMF square. That is 10 by root 2 whole square into 1 divided by 10. Okay, because EMF square divided by R. R is 10 because it is 10 ohms resistance over here. Okay. Now, my dear friends, I can say power is equal to, this is 100 divided by 2 into 10. So that is 5 watt. 2 into 10 is 20. That is 5 watt. So power in this case is coming out to be 5 watt. Now listen to me very carefully. Listen to me very carefully. My dear friends, this power is 5 watt. Okay. Now, if I say, see, if I say the circuit is something like this, the circuit is something like this. Okay. Guys, this is a very important question. And this is, let's suppose you have got an AC source, this AC source, okay, that is given 10 sine of omega t, and this is 10 ohms. And if somebody asks you how much is the power loss, you say, sir, 5 watts in this case by using the formula. But since you have got a diode connected in this case, sir, what is the work of the diode? I have told you before, if you remember, my dear friends, we say the current can enter from the back side of the diode. Current can enter from the back side of the diode, but current cannot enter from the front side of the diode. Already discussed. So we say, my dear friends, this is an AC source. It supplies the current in this direction. It supplies the current in this direction. We say, sir, this one. And we say, sir, this one. This will be the positive cycle. This will be the negative cycle. Because alternating current means bidirectional current. So it will send the one cycle from this side, another cycle from this side. So this current cannot flow through this diode, but this current can pass. So we say, if total power loss is 5 watt, we say, sir, if only one cycle is passing, how much will be the power loss? So that is 2.5 watts only. That is 2.5. Why? Because only one cycle is passing. So we say here power loss is 2.5 watts only. Because diode is allowing only one cycle of alternating current. Alternating current is a bidirectional current. Hey guys, I hope you liked this. Everybody out there. And this is the last question which I'll keep you as a homework over here. Homework, okay? Do solve this question and let me know the answer of this question in the comments down below, okay? And most importantly, my dear friends, do like this session, everybody out there, and comment down below. Comment down below, how was the session? Did you like the questions, everything and all? Did you like the questions, everything and all? I want you guys to comment down below later on, okay? Later on, I'll end the stream and you comment down below, because that is mandatory, because That is mandatory, because that is mandatory, okay, over here. So all the people out there, do comment down below, because every time we keep on seeing your comments, we just get energy, just gets boosted, okay. So that's it. Thank you so much, guys. See you guys in the next class. Till then, bye bye and take care. Till then, bye bye and take care. Okay. Okay. Thank you so much, guys.